So as we said, we can replace Qn by mCp times during combustion, the temperature will be elevated from Tc to Tz. So T at point Z minus T at point C. Sorry, this is here we are replacing Qn, but what we want to do is actually we want to replace Q out. Okay, so I will put this term for the denominator. This is for the denominator mCp Tz minus Tc. Okay, for the numerator, I need to put Q out. So let us take this to the. This is term at denominator. Okay, and now for Q out. For Q out, we have heat rejection at constant volume. So we can write Q out as mass times CV because it's a process at constant volume. So sensible heat is written as mCV delta T. And here delta T, we take it as absolute because we set the Q out. Yani we know that we are losing it. That's why we consider here a minus. So now we take the absolute value of temperature change. So we do TB minus TA because temperature at B is larger than temperature at A. And now the masses can simplify. So we have calculated the thermal efficiency in another way. So if you just know the temperatures at the extreme points of your cycle, you will be directly able to calculate the thermal efficiency of your cycle. Okay? Now, we also have a question. They told us that considering that the efficiency, the combustion efficiency of the cycle is 90%. Deduce the heating value of the fuel. Okay. How can I deduce the heating value of the fuel if I know the combustion efficiency? Do you have any idea about this?
بس شو يعني heating value؟
شو يعني heating value? Okay. You remember when we discussed fossil fuels last time? We said that each fuel, okay, is characterized by a heating value. And if I burn 1 kilogram of this fuel, it will, let's say, it will release a certain amount of heat. Okay, so let us consider. I give you Q heating value in joule per kilogram. And if you burn 1 kilogram of this fuel, you will be able to extract this amount of heat. So each 1 kilogram burnt will be able to release a certain amount of heat. Okay, so each fuel is characterized by its heating value. And if you remember, we discussed you have an upper limit for the heating value and a lower limit for the heating value. What is the difference? We know that each fuel contains a certain amount of humidity. So whenever it will burn, okay, you have a certain proportion of this heat will go to evaporate water. So that's why this heat will be lost and we are not able to recuperate it unless we do condensation of water to recuperate the heat of evaporation. Okay, so actually during combustion in general, we give the low heating value because this is the one that we will be able to use. While when we give the high level, the high heating value, it corresponds to the amount of energy released if all quantity evaporated can be condensed. If we can restore the heat of evaporation. So this is the heating value, Joseph. Okay, whenever you burn a certain fuel, it will release a certain amount of energy, and this characteristic is a very important characteristic for fuels. In general, we search for fuels with high heating values. Okay, now. What is the combustion efficiency? Whenever you have a fuel and you burn it, okay, you know that you have some losses. In general, you can have some incomplete combustion or not the whole amount of fuel will be able to be subjected to combustion. You have some losses. So from here, we define the combustion efficiency. The combustion efficiency, if you want, it's Q released during combustion, okay, over the maximum possible heat, which is what? The heating value, okay? But please pay attention here. Since the heating value is in joule per kilogram, so here I should have also Q released should be computed in joule per kilogram, okay? So the combustion efficiency is defined as the actual heat released during combustion in joule per kilogram over the heating value. Now, if I want to apply this to my cycle, what is the heat released? Where did I use this heat? In which step? In which step of my cycle?
بس يعني heating value is the heat released assuming perfect combustion.
Yes, and assuming you don't have any losses, okay? You don't have any losses of fuel. يعني if the whole quantity will burn, then you will have the heating value. But actually, when you introduce the fuel in your engine, you have always losses. يعني here you can consider losses from the reservoir of fuel to your cylinder. You have some losses, okay? You can consider that if I have a certain fuel, when I say I burn 1 kilogram, if it will burn completely, I don't have any losses through my system, it will release this amount of energy. But actually, you know that you have the transmission of fuel, you have when it's introduced to the cylinder, if it's not mixed perfectly with air, you can have some losses, etc. And you have some losses that will lead to if you want that your combustion will not be perfect. Whenever you can just say the real input is Q input. And here when you did the cycle, you considered that the combustion will release Q input. And this is the actual value that you calculated in your cycle. But actually, is this the maximum possible value that I can extract? If I consider all possible losses of fuel, okay, or if I have, let's say, some residuals that are not that didn't undergo combustion, this means that I have losses. So Q input in joule per kilogram, to have it per kilogram, what should you do? You can say that Q released is Q input over M, because we calculated Q input if you want, in joule, okay?
In joule.
If we divide it by the mass of fuel that we have, Qn over M will give us Q released in joule per kilogram actual, in the actual cycle, while the maximum possible value that can be extracted is the heating value. And if I consider no losses of fuel at all and the whole quantity is burned, okay? So here, if you want, in your cycle, how you calculate Qn? You can calculate Qn as mCv delta T, okay? And also you can calculate the Qn as the thermal efficiency times W net over the thermal efficiency, because you know that thermal efficiency is W net over Qn. So in case you calculated, if you want, the thermal efficiency from temperatures. So if you calculated the thermal efficiency from temperatures and you already have computed W net, you can deduce the value of Qn from this equation. And you can say that Qn is equal to W net over the thermal efficiency. This is, if you want, the actual, the useful input that you are able to extract from your cycle. But what is the maximum possible input that you can have? It is it is the case when you don't have any losses in your when during the combustion of your fuel. This is why we say it's the combustion efficiency, because during combustion you can have some losses, some residuals, or some quantity of fuels that didn't burn during combustion. Okay, so this will lead to some losses, and because of this, in general, this factor is really high because we can minimize losses by proper design. Okay, but it can be, it's in general above 90%. So since we have the efficiency, it's given, and we calculated Q released as Qn per unit mass in joule per kilogram, so we can compute what is the heating value. So the heating value of our fuel can be calculated as Q released over the efficiency. Okay, and Q released is Qn over mass. Okay, 1 second. So over M over the combustion efficiency. And in this way, we can determine what is the heating value of our of the mixtures that we used. Okay? Any question on this? If you replace numerically, okay, you will get, I will type for you all answers, okay? So you will get that the heating value is 39.167 kilojoule per kilogram. So you can compare it with common fossil fuels that we have seen in chapter 4. In chapter 4, if you remember, we have a table summarizing for different fossil fuels what is the heating value. And higher the heating value, the better is, because we can extract a higher amount of joule per unit mass. Any other question before we stop? Okay, good luck for your
Thank you, Professor. See you.
Welcome. Bye-bye.
Thank you so much, Professor.
Welcome. Bye-bye.